Good morning, everyone. Once again, this is Dr. Ray Science. I know I've been away for a while. I apologize for that. So, there's a question here I want us to work together on. A very simple one. A man is pulling a box with a string inclined at 30 degrees to the vertical. If the man applied a force of 32 Newton to the 18 kilogram box, that the box moved a distance of 10 centimeters. Calculate the work done by the man on the box. Okay, for physics students, in most schools they learn this in grade 4, grade 10. In some schools it's grade 11. It's a very simple one on work, energy, and power. Now, when you see something like this, friends, I will tell you, try and see if you can sketch what is going on. It can help you to kind of visualize it and make better decisions, okay? So here is my 18 kilogram box. The line I wrote here with the dash under is the ground where this box is seated. And here is my man standing on the ground. Here is the rope with which he's pulling this box, okay? The force is applying to pull the box acts through the string, which is this line I drew like this. That force he applied through the string is 32 Newton, okay? Notice another thing they told us, that this string, he's not pulling vertically to the ground, that means parallel to the ground, no. That the string is actually inclined at an angle of 30 degrees. So I tried to draw a vertical line to show the 30 degrees of inclination of this string to the vertical. And when I do that, I could say that here is perpendicular 90 degrees, okay? So for this right angle triangle, if I have here 30, here is 90, of course here should be 60 for me to complete the angles in a right angle triangle. Now, what's the easiest thing to do? Friends, go and write out all the information given to you and you'll be good to go. Friends, from the question, we saw that the force was 32 Newton, okay? The distance was given as 10 centimeters. Remember, the unit for distance is meters. So this means the same as 10. This C is actually 1 over 100. Then this M is the meter where you want to turn it. So this becomes 10 times 1, 10 divided by 100, 0.1 meters. Now, do you remember the formula work equal to force times distance? Of course, that's a common formula we use. Now, this formula is true if, okay, if the force causing the object to move is acting parallel to the distance where the force is moving. If that is not true, you can't use this formula this way, okay? Now, why did I say that? This force caused this object to move this way, but the force itself is not applied parallel to the direction the object is moving. So you need to resolve this force into vertical component and horizontal component. So I am saying here is f of y, and here is f of x, and here is f. So for the right angle triangle, here is a hypotenuse. Considering this angle, you are free to use this one if you like it. This side is opposite to this angle. This vertical is adjacent to that angle. So which force acts along the ground where the object is moving? It is f of x. You can see it is horizontal. So it is going parallel to the ground. So you see f of x over f is equal to sine 30. That means f of x is f sine 30, right? If you do that, you can now go back to this formula. The work done is, other than writing ordinary x, you are writing f of x. That's the big deal there. If you remember that, it's very easy to sort out. Times 30 multiplied by 0.1. So the f is 32 times sine 30 times 0.1. Okay, having done that, what do you see? 32 sine 30 is 0.5 times 0.1. 0.5 times 32 is 16 multiplied by 0.1. So work done is, this is 16 divided by 10, okay? So this is 1.6 joules, and that's the correct answer. Thank you.